Dart Skill presents Introduction to Probability. Probability is the chance or the likelihood of something happening. It is expressed as a percentage, a decimal, or a fraction. Let's say we throw a dice. I'm sure you must be knowing what a dice is. It's a cube with the numbers 1 through 6 printed on its 6 faces, one number on one face. If you make a random throw of a dice, what is the chance that the number shows up is 2? Is it the same as the chance of getting a 5? There can be several questions to answer, but let's first learn about a few terms we expect to come across. An experiment is something that we do. Basically, it's the context in which a problem is set up. For example, we throw a dice, or maybe toss a coin, and so on. Like I said, it's the context of the problem. A trial is a single iteration of an experiment. Single iteration of an experiment. Now, what I mean by a single iteration is, let's say you perform an experiment of throwing a dice 100 times. So the experiment is comprised of 100 trials, such that each throw is a separate trial. An outcome is the result of a single trial. For example, getting a 2 when you throw a dice, or maybe getting a heads when you throw a coin, or when you toss a coin. We define the sample space as the set of all possible outcomes. In the context of the experiment, when you throw a dice, the sample space is going to be the set of numbers 1, 2, 3, 4, 5, 6. Because you will have one of these numbers showing up, and the number that shows up is not outside of this set of this list. An event is a combination of one or more outcomes of the experiment. For example, we could define an event, let's say define the event A as, when you throw a dice, a multiple of 3 shows up. Typically, you want to find probability of events or combination of events. There's also something called theoretical probability. And experimental probability. Theoretical probability is the calculated probability. So you do some math to find the probability of certain events. And it's given by the formula, the number of outcomes favorable to a particular event, divided by, so this is a fraction. Remember, a probability can be expressed as a fraction, a decimal, or a percentage. So this is the fractional form, divided by the total number of possible outcomes in the entire sample space. Let me give you a couple of examples. Coming back to that same experiment of throwing a dice, let us try and find the probability of getting an odd number. P odd is equal to, now if you think about what can happen, the total number of possible outcomes across the sample space, that obviously is 6. You could either have a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Now if it has to be an odd number, there can only be 3 possible outcomes that is favorable to the odd number event, that is 1, 3 and 5. So the probability of getting an odd number is 3 out of 6, which is simplified to 1/2. Or if you want to write it as a decimal, it's 0.5 or 0.50, whatever. Or if you want to write it as a percentage, it's 50%. And if you want to find the probability of a multiple of 3 showing up, let's say a multiple of 3. So you throw dice, what is the probability or what is the chance or what is the likelihood that the number that shows up on the top is a multiple of 3? Now there are 6 possible outcomes. The denominator again is 6. And you just want to find out which are the multiples of 6 that can show up. And that's only 3 and 6. You have only 2 multiples. So this is going to be 2 out of 6, which is 1/3 or 0.33, which is equal to 33.3%. Two important things to note. An impossible event, has a probability of 0. And that's pretty obvious. Now, if I were to ask you, okay, you throw a dice, and what is the probability that the number that shows up on the top is 8? Well, the dice has got 6 faces with the numbers 1 through 6. You cannot have an 8, so that's an impossible event. The probability, the chance of getting an 8 is 0, absolutely 0. There is no number of favorable outcomes to this event. So the numerator of this fraction is 0. The denominator still is 6. So 0 over 6 is 0. And then there's something called a certain event. Certain. Again, the name implies it has a probability equal to 1, or you could say 100%. It's certain to happen. Now, what if I asked you that when you throw the dice, what is the chance that the number shows up is either an even number or an odd number? Well, whatever that number is, it's either going to be even or odd, right? So this number on the top, number of outcomes favorable to an event, it's for even it's 2, 4, 6, 3, and for odd it's again 1, 3, 5, 3. So you have a 3 plus 3 on the top, 6, and a 6 on the bottom. So 6 over 6 is 1 or 100%. An experimental probability, on the other hand, is about finding the probability by doing the actual experiment. Let's say you pick up a coin and you start tossing it. So either you get a heads or you get a tails. The theoretical probability tells you that the probability of getting a heads is the same as the probability of getting a tails, which is equal to 1/2, provided of course the coin is unbiased or it's a fair coin. Now if you toss the coin 2 times or let's say 10 times, it's kind of unlikely that you get the same exact number of heads and tails. Maybe you get 7 heads and 3 tails. You never know. When you toss it 2 times, maybe both times it shows a tails. Now when you keep repeating that trial, the number of trials in that experiment goes higher and higher. 50, 100, 200, 500, 1000. The probability will start making some sense. Because you will see that as the number of trials goes higher and higher, the experimental probability gets closer and closer to the theoretical values, which means the number of heads and the number of tails are going to come closer and closer. So that was just an introduction to probability, a very important topic in math.